Thanks for joining me here for part 3 of the unit circle. We've been learning a lot so far in parts 1 and 2, including how to convert from degrees to radians and back and forth, this idea of what's called a reference angle, knowing that at 30 degrees there are certain exact values for sine, cosine, and tangent, same thing for 45 degrees and 60 degrees. And so once again, these are exact values, not approximate values. We've also learned that x is equivalent to cosine of an angle, and y would be equivalent to sine of that angle, and that tangent is y divided by x, or sine divided by cosine. And finally, we have learned that certain functions are positive in certain quadrants. And this shows that all of them are positive in quadrant 1. Only sine is positive in quadrant 2, only tangent in quadrant 3, and only cosine in quadrant 4. So in this video, we're going to kind of put this all together, do some various odds and ends, and seeing how all the pieces fit together. Let's get it on! So let's go ahead right now and just dive right into this. So first thing we're going to do is find the exact values of, in this case, sine at 120 degrees. And you'll notice here on our chart, we don't have 120 degrees. We actually have 30 and 45 and 60. So what we're going to need to do is this. We're going to need to figure out where 120 degrees is on our unit circle. So on our unit circle over here, this is 0 degrees, 90 degrees at the top. On the side over here, that'd be 180. So 120 degrees would be right here. And if this is 180 degrees, and it is, that means we're 60 degrees away from 180, away from the x-axis, which means our reference angle is 60 degrees. So I'm going to write that right over here. Our reference angle is 60 degrees. So what we're going to do is we're going to say to ourselves, well, what is sine at 60 degrees? Well, here's sine. Here's 60 degrees, and so that value would be the square root of 3 over 2. So that is definitely part of our answer. And then the last part is we need to determine, is this going to be a positive or a negative? Well, in the second quadrant, sine is indeed positive. So that is going to be our answer, positive square root of 3 over 2. Well, what if it was in radian form? Well, first of all, I know many of you are not that comfortable yet converting into radian form, so let's just do that really quickly over here. So I'm going to go 5 pi over 4 times 180 over pi. And when you do this, the pi's cancel out. And basically, if you take 5 times 180 and divide by 4, you're going to get 225 degrees. So that would be over here in quadrant 3. And here is our 225. And we are actually 45 degrees away from here. So our reference angle is 45 degrees. So in this case, we're going to go back to the chart, find 45 degrees, and we're going to find cosine at 45. Well, that's the square root of 2 over 2. So that means the exact value will involve the square root of 2 over 2. And then all we have to do is say to ourselves, well, we're in the third quadrant. What's positive over here? Well, that's only tangent. And since that is not tangent, we're looking for cosine. That means we're going to have a negative. So if you plug down the calculator, cosine 5 pi over 4, and you were in radians, you will get this as an exact answer. All right, well, let's take a look at this here from a different angle here, pun intended. This time we have a unit circle, so we know our radius here is 1, by the way. We have a coordinate, and we have an x-coordinate, we have a y-coordinate. And now what we're going to do is we're going to answer a few questions about that. Let's do the easy stuff first. First of all, anytime we know x and y, we know what cosine and we know what sine are. And x is just whatever cosine is. So in this case here, cosine of our angle is going to be, it's going to be negative square root of 3 over 2. That's just the x value. And sine is going to be the y, which would be 1/2. So two of these are really easy to get here. Tangent would be y over x, or sine over cosine. And so that is going to be 1/2 over negative square root of 3 over 2. Which is going to be negative 1 over square root 3. And we also know, by the way, that's going to be a reference angle of 30 degrees because I see my cosine and my sine are over here. And I'm not really looking at the sines right now. I'm just looking at the values. So, by the way, this will actually turn into negative square root of 3 over 3. And then finally, because we know that x and y would follow a reference angle of 30 degrees. That means we're going 30 degrees in this direction away from the x-axis. And we know this is 180. So if we go backwards 30 degrees, we wind up at 150 degrees. Or if you had to convert into radian form, that would be 5 pi over 6. So that's how this is all going to work here. And it all again comes back to knowing the values for 30, 45 degrees, and 60 degrees, as well as which functions are positive where. As always, if you like what you see, please like, comment, or subscribe. Thank you. And now back to part 2. All right, so now let's tackle the third kind of odds and end here, and that would be we're given an angle, and we're going to find the reference angle, we're going to find the exact coordinates and the approximate coordinates, as well as just draw it on our unit circle here. So 5 pi over 3, if you were going to convert that over into degrees, you would go 5 pi over 3, and you would multiply by 180 over pi. Pi's cancel out, and when you're done doing 5 times 180 divided by 3, you should wind up with 300 degrees. So if you're more comfortable in degree form, go ahead and do that. That means we're going to go all the way around, all the way, and wind up about here. So this would be our angle at 300 degrees. And it also means that our reference angle is going to be 60 degrees, or pi over 3. So that's what we're going to write right over here, pi over 3 or 60 degrees. Either one would be okay. Probably pi form would be better because our angle was given in radian form as well. When we know that, we already know the exact coordinates here using our values here. So x is going to be 1/2. Y is going to involve the square root of 3 over 2. And then the only thing we have to think about is we're in the fourth quadrant over here, which means x's are positive and y's are negative. So that means our y is going to be a negative. So it'll actually be 1/2 comma negative root 3 over 2. And then our approximate would be 0.5 exactly, and then comma negative 0.866. All right, and let's take a look at one more here. And in this case here, 215 degrees would mean we go to 90 to 180, and we're going to be over here somewhere. So here would be 225 degrees. If this is 180, and I said 225, I really meant 215. So 215 is here. The difference between these is 35 degrees. Well, you'll notice here that, wait, it's not on this here. We have 30, we have 45, and 60. So now the question is, well, what do we do if it's not a reference angle of the ones we know the exact values for? And here's what you do. The exact value will be x will be cosine of the angle. So we know our angle is 215. So it'll be exactly whatever cosine 215 degrees happens to be. And y will be sine of 215 degrees. So that's the best you can do here for the exact coordinates. And then if you actually plug these into your calculator, you're going to get negative 0.819 for x. And if you plug sine 215 degrees in, you'll get negative 0.574. By the way, we're in the third quadrant, which means both x and y should be negative, and indeed they are. So this is the last little odds and end here of the unit circle, and that is you're given a point, and our point's over here, and we don't know the x coordinate, but we know the y. And what we're going to do is we're going to try to figure out what x is. So the trick on this one is knowing that if we go straight out from the point to the center, that's our radius, and if it's a unit circle, it's always 1. I'm going to go straight up to make a right angle, and now at this point, I've got myself a right triangle. And I've got, this is my x, this is my y, and my radius is 1. So you can say that x squared plus y squared would equal 1 squared. Well, we don't know x, so I'm just going to leave it alone as x squared. However, we know that y is negative 8 over 17. So I'm going to say negative 8 over 17, and I'm going to square it. And of course, 1 squared is just 1. So now let's do a little bit of fraction work here. So if we square this here, negative 8 times itself would be 64. So we're going to get x squared plus 64. And 17 squared would be 289. You can look it up on your calculator if you want. And rather than writing 1, I'm going to write that as 289 over 289 because I know in a minute I'm going to have to subtract this from both sides. So if I subtract 64 over 289 from both sides, I'm literally going to get x squared equals, and if you take 289 minus 64, you get 225. And then you get over 289. And then the final thing you want to do is you want to square root. And go ahead and take your calculator out. The square root of 225 is 15. And the square root of 289 is 17. And it should be plus or minus. And now you have to ask yourself, is it going to be plus or minus in this situation? Well, we're in the third quadrant. So therefore, whatever x is going to be over here, it's going to be a negative number because we're going to the left or going backwards from the origin. So that means x is going to be the negative version, and that is indeed your answer. All right, well, that's everything you need to know about the unit circle packed into the last few videos. Really hope you got a lot out of it and hope to see you again soon. Thanks for watching.